Alright, so today we're going to be doing basic ionic nomenclature. We're going to start by doing formula writing. Formula writing is really simple. So the first thing we need to remember is that ionic compounds are between a metal, which in this case is going to be barium, and a nonmetal, which is going to be chlorine. And we need to remember that these two carry certain oxidation states or charges. So let's go through and remember what those charges are. So if you're a group 1 metal, you get a +1 charge. Sorry, forgot to put in the 1. Group 2 gets +2 charge. So if you're a metal in group 1, you get +1. If you're a metal in group 2, you get a +2 charge. Then if you're a nonmetal in group 15, you will have a -3 charge. Group 16, you will have a -2 charge, and group 17 will have a -1 charge. So this is where your periodic table is going to come in handy. So barium, symbol for barium is Ba. Barium is found in group 2, which means it's going to have a +2 charge. Chlorine, on the other hand, being a nonmetal, is going to be found in group 17, so therefore it gets a -1 charge. So as you can see, I've written down the symbols and their charges. Now, in order to figure out the formula, you're going to take these charges and do what's known as the crisscross rule, which basically means you're going to take the charges and switch them. So barium, having a +2 charge, switches to the chlorine, and the chlorine's -1 will switch to the barium. Now we're going to disregard the -1. So when we write the formula, barium is going to be left alone because we're going to assume there's a barium in the formula, and then chlorine is going to get a 2 subscript because when we did the crisscross rule, we switched the 2 over to the barium or to the chlorine. This gives us our formula for barium and chlorine. It's BaCl2. So let's do another example. Going to the periodic table, we're going to go to aluminum. Aluminum's in group 13. So group 13 metals tend to have a +3 charge, but not always. Aluminum's a special case. So aluminum symbol is Al. So we're going to write the +3 up here in the corner. Then oxygen is going to be O with a -2 oxidation state. Again, because oxygen's in group 16, oxygen gets a -2. Now, all we're going to do is switch. So Al gets a 2 subscript this time, and oxygen gets a 3. The reason we do the crisscross rule is because we want the charges to equal 0. So by crisscrossing, we get the right number of cations to the right number of anions. So next page. We're going to go through a couple of more examples together. Now if you want to do these examples on your own, go ahead. So lithium is a group 1 metal. Again, it's going to have a +1 charge. Iodine is a group 17 metal, so it's going to have a -1 charge. Because we're going to do our crisscross rule again. So when we do that, we get LiI. Notice I don't have any subscripts here. The reason is, since both of these have a plus or -1, we don't need them when we do the final formula. Strontium chloride, so we're going to do Sr, because that's the symbol for strontium. It's a group 2 metal, which means we're going to do 2 plus here. Chlorine's a group 17 metal, so we're going to do a -1 here. So again, just crisscross to get your formula. So here we're going to get SrCl2. Aluminum nitride, Al, gets a +3 charge. Nitride gets a -3 charge. So when we crisscross, we're going to get Al3N3. But because we have the same subscripts, we can reduce, which basically means we're going to simplify the subscripts. So we're going to make it Al and N. You always want to reduce if you have the same subscripts. We're going to do one more together. So sodium symbol is Na with a +1 charge. Sulfur, which is what sulfide means, has a -2 charge. Crisscross them. And you get Na2S. Potassium oxide. Remember, potassium is a group 1 metal, so it's going to have a +1 charge. Oxygen is a group 16 nonmetal, so it gets a +2. Crisscross, and you get your formula of K2O. Now, when we name basic ionic compounds, we name the first ion or the cation. So we're always going to be doing the positive ion first. Step 2 is you're going to take the anion, which is the second ion, and change the ending of the base or root to "ide." So in this case, Al2, aluminum, so we didn't change the metal's name, and oxygen. So we changed the base for oxygen is ox, and we just added "ide," so it's oxide. So let's do a few examples together. BaCl2. So the anion, or the cation, is Ba. So if we look up the periodic table for Ba, we'll find out that it's barium. Then we look at what Cl is. Cl is chlorine. But we're going to change the ending. So the base of chlorine is chlor, so we're just going to change the ending from "ine" to chloride. So it's barium chloride. CaN2. Well, the cation here is calcium, so we always name the positive N first. Sorry, I think I'm misspelling that. So let me erase that L. And then looking at our anion, it's nitrogen, so it's the base or root is nitr. And then we're just going to add the "ide," nitride. Last one. Here we have Kf. Our cation, or metal here, is potassium. Our anion is fluorine, so we're going to call the second part fluoride. So remember, you always want to name the cation first, then you want to name the anion. And that is all for binary basic ionic compounds.